doing something. You have this quadratic sequence, and it has the second difference of 10. The second difference is 10. The first two terms are equal. That is, term 1 equals term 2. And they said also, term 1 plus term 2 plus term 3 is 28. And they then said, show that the general term of the sequence is that one there. It's 5n squared minus 15n plus 16. Okay, so we actually will do the question over here. Right, so how do we do this question? Right, so we shall start the solution anywhere. We can start the solution here. Right, so we are looking at this solution right now. Right, we're looking at this solution. Right, looking at this solution, we have the following. Right, we have the following. So what do we have? We have the first two terms, right? Because they said the first two terms are equal to each other. So we can make the first term x and then the second term x so that the first two terms are equal to each other. And then we have the third term of the sequence. And then this pattern obviously continues there like that. Okay, so we have that. Right. We continue. Okay, if we have these, what next then do we say? Right, so we can get the difference here and say, we have this, we have this. What is x minus x? It's 0. And then we have T3 minus x. And then you have this minus that. What is this minus that? T3 minus x minus 0. Okay, the second difference will therefore become what? 10. And as a consequence, the realization is therefore that 2a. Okay, because now when we get to this point, we remember something. I need to state that. So we remember something. What do we remember? Right, we need to remember that this one is 2a. So 2a is 10. And then this one is 3a plus b equals this one. And a plus b plus c equals the first one. Right, so if 2a is 10, what does it mean? You divide both sides by 2. 10 divided by 2 gives us what? Gives us 5. So we have achieved that one. Okay. Okay, we continue. Right, so it therefore means at this point we have 3a, right? So we have 3a plus b equals 0. If 3a plus b equals 0, but a is already equal to what? A is already equal to 5. So it is 3 into this plus b. Okay, so what do we then get? Okay, right. So we continue. Right, we continue. What do we get? Okay, so from these, we're able to see, therefore, that b equals minus 15, okay? Which is this one, right? Remember, the examiner just said, show that the general term is that. So now, after this, we want to, it remains to find the value of what? Of c. Right, how do we find, therefore, the value of c? Right, to find the value of c is obviously a very interesting thing. Right, and I'm sure you can share your own thoughts on that. Right, so what do we get? Okay, yeah, what do we get? Okay, what do you think you can, how do you think you can get the value of c? Okay, we need to talk. Okay.
plus B plus C, which is going to
B
be
plus
5
C
plus
is gonna
negative
be
15
mm-hmm,
equals to C.
equals to C. Okay. You think we can use A plus B plus C? Okay, because we can, you know that A plus B plus C is X, right? Well, we know that.
Yes.
Yeah, okay, yeah. I mean, we're just talking here. Okay, so yeah. Okay, yeah. Anyone? You talk. Doesn't matter. But yeah, we need to. Okay, so we know therefore that. So C is the tricky one. C is the tricky one because we need to find the value of C, but how do we find the value of C? So to find the value of C, there are a couple of realizations you need to make. And a couple of things, we need to use the equation A plus B plus C equals X. Because that is the equation we always use. We always use, to find C, we always use A. Because to find A, what do we use? We start from bottom up when we do quadratic what? Quadratic sequences. So we start with the 2a, from the 2a we get a. From the 3a plus b, we get what? B. And then from the a plus b plus c, we get c. But this says a plus b plus c equals x. But we don't know x. So now it means the first thing we need to do, we need to get the value of x. Because a plus b plus c is equal to x. That is the equation. Right. So how do we get the value of x? I know you can have clever ways to do this. Right. So at this point, it means, but we know that T3 minus x minus 0. If we subtract this one from this one, yes, we say T3 minus x minus 0, the answer is 10. So which means T3 minus x equals what? 10. So we have that. We have that. So what do we get out of these? What do we get out of these? Okay, now at this point, we have another dilemma. What is T3 here? Because we want to get X, but what is this T3? So this T3 now is also presenting a little what? A little issue. So we continue with this now. Okay, we use this equation here. That's why they gave us this equation. Okay. However, we know that T1 plus T2 plus T3 is equal to what? 28.
20.
Okay, that's why they gave us this equation. What is term 1? Term 1 is only x. So we put x here. What is term 2? It's x. So we put x there. Okay, so you put x there. Right, and term 2 is x. What is term 3? So we need to get term 3 out of this. Right, so which means therefore that term 3 is x plus 10. So term 3 is x plus 10 equals 28. Okay. Let's see what this is giving to us. Which means now if we add the 3x's, we get 3x. What is 28 minus 10? It is exactly 18. You divide 18 by 3, you get what? 6. So it means therefore x is 6. After these, we're able to see that if x is 6, then we can come back to the equation that we use. We can come back to the equation that we use to get C. What equation do we use? We use this one first, this one, and that one. Always to do that. So now we thus have that A plus B plus C is equal to X. Okay, because that is the one we need to use to get C always. So we need to write the pattern like this and to always work from bottom up. Right, so what is our A? Our A is exactly 5. Our B is minus 15. Our C is what we want. Our X is what? Is 6. From these, what do we achieve? Right, so we have 5 minus 15, which is minus 10. And then you move it across, it becomes what? 16. Right, so at this point, if this is the case, what do we then achieve? Okay, from this we go up. Right, so we have that this one, the general formula for the quadratic sequences is this one, plus Bn, plus Bn, okay, not the squared. Right, so you have that, plus Bn, plus C, which means that Tn is An squared. What is A? It is exactly 5n squared. The B is minus 15n. The C is what? Is 16. It's exactly what the examiner wanted. It's exactly what they wanted. They said, show that Tn is this, and we just got exactly that. Okay, so I know there are many ways to do this question, but always when dealing with quadratic sequences, you always write like this and make sure we work from bottom up to avoid confusion. But also we sometimes find ourselves with many equations and we'll be like, okay, but what do we do with these equations in the end? Okay, next question. Right, the next question is we're still given the same information, but I've split the question into separate parts to allow easy consumption and for us to be able to break it down. Right, and the question 3.2, because we're doing 3.1, is that is 216 a term in this sequence? Justify your answer with the necessary calculations. Right, is 216 a term in this sequence? Obviously, we recall that. Right, we recall that T sub n is actually, from the previous question, 5n squared minus 15n plus 16. So you have 216 equals 5n squared minus 15 plus 16. That plus 16 minus 216. You deal with this? Okay. So obviously want to know if 216 is a term in the sequence. So we substitute, we equate 216 to the general term, from which we're able to get 5n squared minus 15n. 16 minus 216 is minus 200, equals 0. You divide by 5, which means n squared minus 3n minus 40 equals 0. Okay, so you have this. What are the factors of n squared? N and n. The factors of minus 40, that give minus 3, minus 8 plus 5. Goodness me. Okay, we divide the board like this. Getting n equals 8, n equals minus 5. Which means that obviously this one is not valid because the number of terms cannot be negative. The number of terms can only be positive. So which means that the 8th term is actually 216. Right, so yes, now is this one a term in the sequence? Justify your answer with the necessary calculations. Yes, 216 is a term in the sequence. Right, is a term in the sequence. Okay. Now we proceed to the next question. Right, in the next question, we'll look at graphs and more graphs. So at this point, what we're looking at is how to deal with these graphs here. Okay. Given the function p of x equals 1/3 to the power x. Is p a decreasing or is p an increasing or decreasing function? Blah blah blah, and so on. And I've decided to break this exam question down into digestible pieces because it's quite lengthy. Okay, so we first will look at 4.1.1. Right, looking at 4.1.1, we have this same function, and the question is p an increasing or decreasing function? We answer the question. Right, so what do we know at this point? Right, so there are two things you need to know. There's a function, which is the exponential function. So if you have the exponential function like this, if it happens that the base is bigger than 1, a is bigger than 1, or if it happens that the base is between 0 and 1. So in both cases, what do we do? In both cases, what do we do? Right, so you continue. Okay, anyone? Sometimes I'm going to give you a chance to share your thoughts. What do you think about this question? Anyone? Okay. You can hear me, guys, right? You're scared of the
Yes.
question. You're scared of the question. Okay, because they asked it in June this year and it's there in November. A question like this. This question is there in what? In November. So, okay, I'm just, I'm just teasing you because I just want to see what you think, you know? Because obviously we shall do it together. And I know that you guys are scared of getting things wrong, you know, because obviously, I mean, you wish to get 100%. It's fair. But now, those who get 100% are those who try and what? You try and fail, but never fail to try. And that is the song. And this song is very, very important, you see? Right, so anyone, I'm giving you 2 minutes. Right, 2 minutes. 2 minutes. I'm giving you 2 minutes. Is it too difficult?
Mm.
Too easy. How many marks is it worth? Only 1 mark. Is that correct?
Yes.
Yes. Okay. I was saying, so there are 2 cases. If a is bigger than 1, the base a is bigger than 1, or the base a is what? Is the base a is bigger than 1, or the base a is a fraction between 0 and 1. Like this one, 1/3 is 0.3 recurring. So it is a fraction, and therefore it lies between 0 and 1. In each case, the function is decreasing here. And if this is bigger than 1, an example when it's bigger than 1 is the one we have at hand, like 1/3 to the power x. But if it's bigger than 1 here, it can be like 3 to the power x. So this increases. Okay, so right. So at this point, because you can see that this base is a fraction, is between 0 and 1. So this function is what? Is decreasing. Okay, next question. Right. The next one is they asked for the inverse, and I can tell you this question is there. They're not going to put 1/3 there. They're going to put maybe 3. Instead of 1/3, they're going to put 3. Or they're going to put 1/4. Or just 1/2. Instead of 1/3, they're going to put 1/2 normally. Okay, in November. So then they ask you to say, determine P inverse. P to the power -1, which is the inverse of P in the form y equals that. So this is easy. What do we do? Right, to do this one first, we write down the formula that is given. So we write down P like this.
Mm-hmm.
P has the equation y equals 1/3 to the power x. And then the next thing is now we write the inverse like this. The inverse is the place of y here. In the place of this y, we put x. In the place of x, we put y. So it becomes like this. Okay, so this becomes the log of x base 1/3 equals that. So we make y the subject. If you make y the subject, therefore it becomes y equals log x base 1/3. And this observation is very important for us. So because this is already the inverse. So if this is the case, then we can write from here that this is exactly P inverse of x, which is equal to the log of x base 1/3. So write in the form that the inverse. So you just put here, it is the log of x base 1/3. Okay, and therefore this is the answer, and we get the 2 marks, and we get our distinction. We go to the university and we become medical doctors, we become engineers, and so on. And we move to the next question. Okay, now we need to learn how to write down things. How do we write down this one here? Write down the domain of P inverse. Right. How do you write the domain of P inverse? What is the P inverse? So you recall that P inverse of x is the log of x base 1/3. So that what this is the inverse, then we need to write down its domain. The domain of the log. What is the domain of the log? The log is only real. It's only real for the positive things. And the positive things, so the positive x values, so the domain has to do with the set of the x values. So x is positive, but x is what? Is an element of the set of real numbers. So this is the domain. So x is positive and x is an element of the set of real numbers. Okay. So we get this one here. We get this one here. Okay, let's continue. Let's continue. Okay, all right. I must indicate that there are a couple of ways to write the answer, obviously. It might not exactly be like this, but it can be a different version, in which case you can write it like that, or you can write it differently. How else can it be written? So it can be written in so many ways, right? So if you don't want to write it like this, it may be written as x is an element of the interval from 0 to infinity. Like this. X is an element of the set of real numbers, etc. That kind of thing. So these both answers are that. So you can write as the top, or you can write as the bottom answer. Okay, so we have that. Okay. Right. You need to write down the equation of the asymptote of P of x minus 5. What is the equation of the asymptote of that? Okay, this question is done in grade 10. And at grade 10, the way this is done, at grade 10, you are taught about y equals a to the power x plus that. Okay, normally this is how it's written at grade 10. Right, so we just go back to grade 10, go back in time. grade 10. I know that we're at matric. But at grade 10 now we say A and then we put P to the power X and we put Q like this. Your teacher might have jumped it, whatever the reason. Okay, but now this one is an exponential function. Right, being an exponential function, the couple of things you need to realize. It is an exponential function with what? There's an exponential function with the asymptote. Right, so the asymptote is actually the y, it is the constant. So at this point, the asymptote is going to be what? The asymptote is going to be the q. Right, so the asymptote here is y equals q. So you come here, p of x equals 1/3 the power that. So which means that you have this one to the power x minus 5. Okay, the examiner just said, just write p of x minus 5. And then write down the equation of the asymptote. What is the equation of the asymptote? So the equation of the asymptote is the y. So it is y equals the constant. So y equals minus 5. That is the equation of the asymptote. So the exponential function, therefore, does not have any other asymptotes. There's only one, and it's given by the constant, the q that's there. Okay, the q that's there. So we continue. Now, it's also important for us to be in a position to write down the equations of asymptotes, right off the rectangular hyperbola. Right, so if we are looking at the rectangular hyperbola, what are the asymptotes? So there are two of them. You look at the denominator. So you start and let the x minus 1 equal to 0 and have y equals 2, which means x equals 1 and y equals 2. So at this point, what are the equations of the asymptotes? These are the ones. Obviously, this one here is the vertical asymptote. And this one is the horizontal asymptote. Okay, so this is what we have. We have the vertical asymptote and we have the horizontal asymptote. Okay, so we have solved this one. Move to the next one. Okay, it must be important for us to be in a position to do a couple of calculations like your things. Right. Okay. Obviously, how do we do this one? How do we do this one?
Okay.
Right, so to get the x-intercept, right, to get the x-intercept,
to 0.
good things. Yes, we let y be equal to what? Be equal to 0, isn't it? Okay, that's correct. So we let y to be equal to 0. And if we let y to be equal to 0, it means that if we have the equation that is f of x equals 4 over this plus 2, y is already 0, isn't it? Okay, so we have this plus 2. In this case, you transpose the 2, it becomes minus over this. You cross multiply. So minus 2 is x minus 1 equals 4. Okay. So that you distribute, which is minus 2x plus 2 equals 4, which is equals to 2. So you divide, which means x is equal to minus 1. Right, and therefore this is thus the x-intercept, in which case, therefore, the x-intercept can also be written as a point like this, when x is 0, y is -2, is the x-intercept. Okay, is the x-intercept. So we have this. All right, next question. Right, so the next question is that we continue and solve more things. Sketch a graph of f. Right, sketch a graph of f. Label all asymptotes and indicate the intercepts with the x's. So now we need to draw the sketch. But as we draw the sketch, we need to realize that from the previous questions we got the x-intercepts, we got the asymptotes, we also got the x-intercepts, the asymptotes. We got those, but there's something we did not do. And what is it that we did not calculate? We did not find the y-intercept. So, but now to sketch the graph, the examiner did not ask us to do that. So as part of our solution, we can't draw the graph if we do not know the y-intercept. So we must do it. The examiner did not ask us to calculate that, but we need to, indicate intercepts with the what? With the x's. So, and this axis is plural, because if you speak of only the x-axis, and then you speak of the y-axis, here you speak of x and y-axis. So we have this. Okay, so now at this point, what is the y-intercept? So to get the y-intercept, we simply let x be equal to 0 in the equation. So it's pretty easy. So we put 0 there, and we have this one, 0 minus 1 plus 2, which is exactly -4 plus 2, which is exactly -2. So if this is the case, what are we getting here? We're able to achieve a couple of things, but we already know that at this point, we can be able to sketch the graph. So we need to draw our coordinate axis like this. Our vertical x equals 1. Y equals 2. When we have this. Okay, we got this is the y-intercept, and you can see when x is 0, y is -2. So now we have this one. Here it's going to be at y equals -2. The x-intercept we got at -1. So the graph, therefore, is going to be like this, sort of. Okay. And then now we have another piece that's going to be actually sitting exactly there, like this. Okay, so this is the graph, but obviously we know that this is the y-axis and this is the x-axis. So those are the kinds of things you need to remember. So these are the graphs and functions, but I'm sure that I'm going to give you a lot of problems on the graphs and functions. So you need to get ready, because the graphs and functions are actually coming. So you need to be prepared. I'm going to give you questions of the prelims from all the 9 provinces on the graphs and functions. Okay, so we're going to set time, we're going to discuss that, but that session is going to be a discussion session. So I'm going to share the questions. I'm going to give you turns. Like, you tell me what you think about the Eastern Cape question, about the Gauteng question, about the Western Cape question, about the Mpumalanga question, the Limpopo question, and so on. Okay, so we have drawn the graphs and we're done. Next question. Right, we also must be in a position to use our graphs, to use your graph to determine the values of x, for which this is the case. How do we solve an inequality like this, which involves a rational function? So let's continue with this one. How do we solve these? How do we solve these? So to solve this one, we need to just remember the graph and to realize that the graph was like this, but the graph was also cutting like this. The graph was cutting here at -1, there at -2. So here it was cutting like this. Here it was cutting like this. So x is 1, y is 2, and this one is like that. Right, so we have these. Okay, if you have these, what do we have? Right, so we're interested in the solving this, but now look at the fact that this is x -1 is greater or equal to -2, which means it is x -1 plus 2 is greater or equal to 0. Okay, and therefore this means that we're just looking at the same graph here, because this is actually f of x greater or equal to 0. So we're looking at this function there, but when it is greater or equal to 0 above, sorry, we are here above here, we're there, there. But also here it's greater, because greater means it is positive or 0, and the graph is negative over there. Okay. Or as a consequence, what is the actual meaning of these here? So these would mean a couple of things, but it would actually therefore mean that we have the following. When is it greater or equal to 0? There are two parts. When we are at -1, it is 0 because of the x-intercept, but now it proceeds to the left of -1. And then it also proceeds to the right of -1. For what is then the answer to this here? So which means x is less or equal to -1. Okay, when it is equal to -1, it is equal to 0, but when it is less, it goes up. So when x is less than -1, the function is positive. But it's also positive when we start from 1 here. Okay, so when you start from 1 here, right, so when x is bigger, when x is actually bigger than 1, okay, so when x is bigger than 1, because 1 is the asymptote, right? Right, so we continue. Right. Right, so this is the answer. Because when x is bigger than 1, the function is above. But when x is less or equal to -1, it's also above. So you have that x is less or equal to -1, and or x is bigger than 1. Okay, so it's here and also there. So this is exactly what we get. Okay. So this is what we have. So we have answered this question, but this question can also be written in terms of sets. So you can use the set builder notation. You can use other notations to write the answer. Okay, because we're supposed to just use this to determine the values of that. So we have that. Okay, so next question. Determine the equation of the axis of symmetry of this function that has a negative gradient. So how to find the equation of the axis of symmetry of this? Okay, we need to get our hands dirty. We need to start working very hard. As I told you, I'm bringing all the provincial exams that came in September this year. You need to make sure that you guys can do both papers 1 and 2 for all provinces. And if you can do all the 9 papers, that's 18 exams. It's math paper 1, 9 provinces, and paper 2, 9 provinces. They have that. So now they've given us this f of x minus 2. So we plug it in there. So this is f of x, which is 4x minus 1 plus 2. Right. We have x minus 2 here, which is 4. In the place of x, so you have x minus 2. There's minus 1. Okay, look at these. This is a little bit tricky to the learners because now wherever there is x here, wherever there is x here, we put x minus 2. So wherever there's x here, we put x minus 2, but wherever there's x here, we put x minus 2. So which means, therefore, we have x minus 2, which is exactly x minus 3 plus 2. Okay, so there are a couple of things that are important. So what do we have here? Right, so what we have here is that I want to get the equation of the axis of symmetry, but now we have the point of intersection. The point of intersection of the asymptotes. Right, so where do the asymptotes meet? So they intersect at 3, 2. Okay, if they intersect at 3, 2, then the axis of symmetry, so there are 2 of them. So you always have y equals plus or minus x plus c. So you just choose plus or minus. So at this point, so this one here, they give these are axes of symmetry. Right, so you can either choose one of them. Each one is an axis of symmetry. Right, so you can split it up into the negative and the positive. Right, so if you split it up into the positive and the negative, what do we get? We get exactly that one there. We get exactly that. So this is therefore can be split up. Right. Okay, so this can be split up into y equals x plus c, and this can be split up into minus x plus what? Plus c. So at the end, we need the one with the negative gradient, so we're going to use this one. Right, at this point at where it passes through this one here. So it passes through, this passes through. It passes through the point 3, 2. So y is 2. Okay, we have this. Because this is our x and that's our y. Okay, so our y is 2 and our x is 3. So if we transpose everything, we see that c is equal to 5. So you have this, our c is 5, and that is the answer to this. Okay, that is the answer to this. So we continue. All right. That is the equation of the axis of symmetry that has a negative gradient. How does this axis of symmetry work? Okay, I'm going to just comment on the graph here. We drew the graph like this, and we had an asymptote there. We had an asymptote through 1, and the graph was passing through like this. No? Okay, it was passing through x equal to -1 and 2. So let me just draw a careful one here. So Right. So the graph was actually passing through like this. Goodness me. Passing through this way. Y and X. So for right, so you'd have this one, which is with a negative gradient. So it's gonna actually pass through the asymptote. And then there's another one. Obviously here, when X is that, so right, so you have that. So it is the one that is gonna have a negative gradient. So the equation of this one, there is exactly y equals minus x plus 5, but it passes through the point of intersection of the asymptotes of the rectangular hyperbola, and it has a negative slope, so it slopes down. Okay, right. So we need to get our ends dirty because we need to change you guys. I need to make sure that we come back with level 7 from the exam venues. So you cannot accept to get anything less than level 7. And that is the spirit. We need to work at night. We need to have these class discussions at 8, 10 at night on the days that you are free. Okay? 8 to 10 at night. Later than that, 10 to 12 midnight, we need to have these classes twice a week. Okay, I'm just letting you know because you need to think about this. You need to allocate the time so that you can stay awake on some of the days at night. You can use Saturdays and you can use Sundays. We need to work hard. Okay, now here's another question that came in June this year. And a question like this is coming in November. So it must not surprise you because this is just how the November paper is going to be. But now you need to take it seriously and think about it because they said in question 5, the graphs of the functions f of x is minus into x plus 3 all squared plus 4, right? And the g of x equals x plus 5. These have been given to you. And so you have been asked to do a couple of things. Here's the full question, but I've broken this question down to digestible pieces. So, right, we are going to look at the first one, 1.1, with 5.1, and then we look at the next one, and so on and so forth. Let's look at 5.1. Write down the coordinates of the turning point of F. Okay, I'm giving you 2 minutes. Anyone? Right? Anyone? Okay, I'm gonna involve you guys. I know that it's not that you don't know anything, you know something. Right? Anyone? Okay, you can see the question.
-3 and 4.
Yes. So it's minus 3 and 4. Well done there. So obviously we're looking at the fact that what you have in 5.1 is the answer. We have that f of x is actually minus into x plus 3 squared plus what? Plus 4. And what we are doing here is we are writing down the coordinates of the turning point of f. So the coordinates of the turning point of f are already seen from this form, which is x minus into minus 3 plus 4. The turning point. So the turning point will have to be the minus 3. You must put minus minus and then the number that sits here, which is exactly what? Which is exactly 4. What are the coordinates of the turning point here? They are exactly minus 3 and 4. And that is the answer. Okay. So we go on. Next question. Right. So the next question is just 1 mark. And as I said, sometimes I'm going to engage your thoughts. Anyone? 5.2 says write down the range the range of f. The graph is there. I'm giving you like 2 minutes. I know it's 1 mark. It's too easy. Right. So anyone? Okay. All right. Right. This is too difficult, this one. Because I'm not getting an answer from you, any of you guys. You are 2 guys on the line, you know. I know that you don't know each other. I'm just assuming that Import does not know Waruna. Okay, so you forgive me because I'm trying to make sure that you guys think because I need to exercise your minds. I know you are still learning. I know you are still learning, but I must give you a chance to think. Because if you do, if we have a soccer player who is gonna play for the national team, and then this soccer player does not get into the pitch, and then we expect this soccer player to succeed, you know, it doesn't quite look right, you know, because this soccer player, I'm a coach, because I'm what I'm doing here is coaching. I'm coaching, and you guys must be fit at the end of the coaching process, and I must train the people because if I don't let these players get on the pitch, whoo, they're gonna be too fat. They're gonna sit on the benches and keep eating, 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 and then when it's time to play, they won't even be able to run. You see. Now they'll be like, how have they been coached? The truth is they'll be knowing everything, but they will not be able to run because they never ran during the coaching process. So they need to run. So you need to run and try the range of this. Right? Anyway, I'm just teasing you guys. But now, yeah, we need to work hard. That's my point. So we're looking at 5.2 now. 5.2, you need to write down the range of f. So we look at the function f. So the range is characterized by the turning point. The turning point has the coordinates here. We have seen that the turning point has the coordinates -3 and 4. And so the range is going to begin from here. It's going to begin from there and look at part and consider and continue with part of the graph. But this graph is going down. So the range is y. Is going down. How do you say going down? You say y is less than or equal to the y value there, which is what? Which is exactly 4. Okay. Right. So we continue. Okay, we continue. Okay, so this is the answer. Right. So
And from minutes to infinity.
yes, or we can say that it starts from 4 to what? To negative infinity. Right. So in other words, you can also say y is because it goes to minus infinity. So, but when you write these intervals, then you start from minus infinity, you start from the smallest one, because now negative infinity is very small because it's negative. It's smaller than a positive 4. So, which means you're going to start from minus infinity to 4. So, in other words, you can write any of the answers. You can write that one or this one. All right. Next question. Okay, this one, the answers have been given in 5.3. Right. So you need to show that the coordinates of A and B. But now we can see that first and foremost, A and B are just points of what? points of intersection, all right? So if A and B actually are points of intersection, what do we do with the points of intersection? So now we need to equate them. So the answer to 5.3 would be as follows. So we'll add f of x be g of x. So f of x is x plus 3 squared plus 4. The g is x plus 5. So you square these. So this is x squared plus 6x plus 9 plus 4, which is x plus 5, which is x squared minus 6x minus 9 plus 4 is x plus 5. Okay, we have this. All right. So we continue. We continue. Okay. Right. So we have this. So what is this? This is therefore minus x squared minus 7x, because you have minus 6, and then if you bring the x, it becomes negative, right? And then we have minus 9 plus 4, which is minus 5, and then you bring down the other 5, which is minus 10, equals 0. And therefore, which means is x squared plus 7x plus 10 equals what? 0. In which case, you have these. So the factors of x squared become x and x. The factors of this becomes 5 and 2, and you have plus, plus. So which means x is minus 5 or x is minus 2. So they said minus 5 and minus 2. So which means therefore at A we have x equal to minus 5, and here we have x equal to minus 2. Okay, so this is what we have. Right. So we continue. We continue. Next question. Right, so we have this particular question here. And this question says that the graphs of the functions f of x and g of x are drawn below, hence determine the value of c for which the equation, this one, minus into x plus c plus 3 squared plus 4 is equal to x plus c plus 5. It has one negative and one positive root. Okay, so what is the answer to this? Okay, I had lost Waruna. Okay, never mind even if I lose you, because this is recorded. So I can lose you sometimes if there's a problem. Okay, if I lose you, this is recorded, so you're not gonna miss anything. That is guaranteed. So just to take note of that. Right, so we continue with this discussion right now. So at this point, we have that the graphs intersect at A and B, hence determine the values of C. Right, for which the equation has, for which values of C for which this equation has one negative and one positive root. One negative and one positive root. Right. Okay. Right. I just welcomed Marang to a discussion as well. And we're going to be discussing as well with Marang. Marang is our friend as well. So we are continuing our discussion. Once again, this is recorded. So yeah, Everybody will get the recording of this at the end of the discussion. Right. I need to confirm if Marang, you're able to see our screen. Are you able to see our screen, Marang?
Morning, sir.
Yes, good morning. And how are you, Marang?
I'm good and you, sir.
Very well. I need to confirm if the screen is visible to you. Is it visible?
Yes, sir.
All right. We have a question. So what you need to do is just need to watch because this lesson is recorded. I'm going to send you the recording at the end of the lesson. So, but now you just need to watch and make sure that you participate of this lesson. Right.
Yes.
Right. We have the two graphs, f of x and g of x, which are drawn below. The graphs intersect at A and B, so we can see that they intersect at A and also at B. Hence, determine the values of C for which this equation. Okay, look at this equation. And they're saying this equation has one negative and one positive root. Okay, now let's think of this question very carefully and make sure we can make sense of it. But what are the values of C and what is the answer to this question? I know that it's an interesting question. Let's Cedric, these questions, where are these questions coming from? They are from this year's June paper. So this year's June paper has set the prelude for the November exam. So there are actually questions pretty much like these already. But there are a couple of things we need to remember that we actually were able to calculate that this was -5 here, and at B here we had -2. Okay, we did that. And so now if the examiner decides to equate these two functions, but also this examiner is very clever, is adding C. Okay, if you have this and you add C, and then you have 3 that is there, you square everything plus 4. You have this one, you have this. Okay, you have these two. What is the examiner doing here? He's actually adding C, and then he's equating the two. And then the examiner is saying, if these are, the C has been added, the examiner is then saying F equals G. And then the examiner is saying, we must find the values of C for which this equation has one negative and one positive root. Okay, this examiner is translating the graph because if you add a C, the graph is going to be translated. It's either going to move to the right or to the left. So let's understand. Now, if we want that here we have one negative and one positive root. So what does it mean? It means that at the point at which the two graphs intersect, because now they intersect and they intersect at -5 at -2. How much can we move these graphs by? We can move it by 2 units, for example. If you move the graphs by 2 units, then this point B is going to be like here. All right. And then this point here is going to be at a -3, for example. Okay. But if you move it by 2 units, this is going to be there. So you need to now perform further adjustments. And I'm going to state here exactly what needs to happen. So we state in words. Here's the answer to 5.4. We're just talking before. The graph must shift. So this is a shift or a translation. It is a transformation of the graph. Must shift more than 2 and less than 5 units to the the right. Okay, so the graph must shift more than 2. So because if it shifts only 2, it's going to be here. So the point B is going to be like on the y-axis. But so it must shift more than 2. Yes, please. Okay, that's fine. So it must shift more than 2 in less than 5 units to the right. So this means that our C, which demonstrates the shift, is going to actually lie between -5 and -2. Sorry, they said determine the values of C. So these are the values of C. Okay, and we got the answer. So think about it. But this is recorded, so you'll watch these again during your own leisure. Next question. Okay, right. So if we have now this one, what do we do now? Okay, we have graphs and functions. And now I know they're important because I got some discussion. Some students told me that graphs and functions are a little bit interesting. Okay, let's look at this one here. This one was given 5 marks in June this year. So this is this year's June paper for the kids who write in June, mathematics grade 12. Right, there's also write in November, but the November paper will be very similar to this one. Okay, we have these two graphs, F and G. They are drawn below. The graphs intersect at A and B. We ask the question, the maximum distance between F and G in the interval. So in the interval XA and XB, right, is K. If H is G plus K, determine the equation of H in the form that H of X equals that. What is the answer to that question? Right, so anyone? How do we start this question? Because what do we want? We want the maximum distance. So how do we find the maximum distance? So in the matric exam, because this question is going to be there. Okay, this question is going to be there in the matric exam. Okay, we begin as follows. The distance. The distance becomes f of x minus g of x. Okay, that is the distance, because now at this point, we want to say the maximum distance between f and g in the interval is k, right? So we want to find the maximum distance between the two functions, right? And so now we can be in a position to find it in a couple of ways. So there can be negativity and positivity, but we note that this is the graph of f and this is g. So in the parts, for instance, like here, we can be able to see that the graph of f is above between A and B, and the graph of G is certainly below. So we can therefore say f of x minus g of x, in which case, therefore, we have the d of x, right? We have the function f of x, which is exactly minus into that. You square these plus 4 minus. What is the g of x? It is actually x plus 5, from which we're able to achieve the d of x. We square everything here, right? So if we square everything, we have the negative outside. If you square a binomial expression, it becomes exactly x squared. The next is x by 3 by 2. X by 3 is 3. X by 2 is exactly 6x. We square 3. 3 by 3 is 9. We add 4. We distribute the brackets by the negative sign, from which we obtain d of x equals minus x squared minus 6x minus 9 plus 4 minus x minus 5. So which means the d of x equals minus x squared minus 7x. Okay, so obviously at this point you have minus x squared minus 7x. Okay, so you have minus 9 plus 4, which is minus 5 minus that, which is minus 10. Okay, so what do we then get at this point? So we want to get the maximum. So at this point, the maximum, right, occurs, because this is quadratic, occurs at the x value of the turning point. The turning point is minus b over 2a, which is minus, the b is minus 7 in the quadratic. So we have minus 7 over 2a is minus 1. And therefore, the answer is exactly 7 out of 2. After we got this value here, we are able to find the result the examiner wants. So we are able to get the d of 7 out of 2. Okay, we have the d of x is this one. But the d of x is minus x squared minus 7x minus 10. So it is actually minus into the x is 7 over 2, which is square, minus 7. The x is 7 over 2. And we have minus 10. As I said, we need to train like soldiers very soon. If you use your calculator, you'll see that the answer here is 2.25. And then after this, we are able to see that this is the distance. Right, and this distance here is exactly that one. Please note that at this point, this 7 over 2 is negative, so that here you will have a negative as well. Okay, so that you'll have a negative. Let me just write clearly here so that you have the additional negative sign, and everybody understands actually here. Okay, so you have the negative, so you'd have the negative 7 over 2, and this is actually minus into the x itself is what? Is minus 7 over 2, right? Which you square minus 7. The x is minus 7 over 2, right? And then you have minus 10 like this. And therefore, if you use your calculator, you realize that this is exactly 2.25. Okay, we have this. And then, right, so after we got this, we are saying therefore the distance, which is the maximum distance between the two functions, is 2.25. Okay, so but they said the maximum distance between f and g in the interval x between xa and xb, between the xa and the xb, this distance is k. So the implication from this is therefore that k itself is 2.25. Okay, if it is true that it is 2.25, then what is the age? What is the age? Right, so it means, therefore, we're able to see that the h of x must be actually in this form. So remember that h of x is g of x plus k, and g of x is x plus 5. So we're going to have x plus 5, but the k is 2.25. And therefore, the result is you add this here. It's x plus, what is 5 plus 2.25? It is actually 7.25 there. So now we need to determine the equation of age. And so we have found the equation of age. It is actually 7.25, but most importantly, k is 2.25. Okay, we continue. Next question. From the 2023 metric exam from the Department of Education. Right, the next question is about finance. Right, so finance is also extremely important for us to understand. So this is what they asked in the finance part of the metric exam. And they're speaking about a company that bought a photocopier for 150,000 on 1 July 2022. They will use the old photocopier as a trade-in when they replace it with a similar new photocopier in 5 years' time on 30 June 2027. Okay, so we have exactly that part there. And then we're asking the question, determine the average rate of inflation over the next 5 years. Right, they're saying the average rate of inflation over the next 5 years will be 6.5% per annum. Determine the price of a similar new photocopier in 5 years' time. Okay, what is the answer to this question? We solve the question together. So this one is easy because it's just giving us all the information. They're saying the average rate of inflation over the next 5 years, will be 6.5% per annum, and we just need to calculate the price. Okay, so this is what they asked in June. So let's solve this question from the June 2023 metric exam. Okay, so now at this point, there are a couple of things we need to note. We have been given data. What is the data that the examiner gave? So they've given us the present value. Remember, this company bought the photocopier of 150,000 Rand. So which means, therefore, this one is 150,000 Rand. Present value. Right, the average rate of inflation is actually this one here, per annum. Okay, so what is the average rate of inflation? It is actually I equals 6.5%. Per annum, you divide this one exactly by 100 and it becomes 0.065. Right, per annum. Because percent means you divide by 100, so you get exactly that one. And obviously, we realize that we've been told that the average rate of inflation over the next 5 years, so which means N is actually 5 years. Okay, we are, well, in business, so now we can continue and find these here. We need to, what are we supposed to do? We're supposed to determine the price of a similar new photocopier in 5 years' time, subject to inflation. So in other words, the price of the photocopier in 5 years' time is going to be higher. So we're going to use the appreciation formula with a plus. We expect that inflation means that the prices are going up. Right. So so the P is 150,000. 1 plus the I is 0.065. You raise it to the N, and N is actually 5 years. So you multiply everything here. So if you are able to get these, which is 205,513. Okay, so we have exactly this one. Right, so this is exactly the answer if you use a calculator. So the average price of a new similar photocopier in 5 years' time. So a new photocopier in 5 years' time will be costing this much. Will be costing that much. So we continue. You're right, we continue. Right, so this is 0.5 there. Okay. Okay, let's look at the next question. And the next question is very interesting. It's just more finance as well. Right, we have been given the same story about the fact that a company bought a photocopier for 150,000 on 1 July 2022. They will use the old photocopier as a trade-in when they replace it with a similar new photocopier in 5 years' time on 30 June, at the end of June, that is, you see, 2027. 30 June, obviously suggests at the end of June. And obviously, the photocopier was bought 1 July 2022. So we're going to use a timeline to interpret this question to make sure that our interpretation is very clear. But we need to calculate the trade-in value of the old photocopier after 5 years. If it depreciates at a rate of 9% per annum on a straight line method, what is the trade-in value of the old photocopier? Right, so the couple of things obviously you need to consider. So in finance, it's very important to write down the data so that we can decide on which formula to use. But we have been given here the present value of the photocopier at which the price at which it was bought. It was bought for 150,000 Rand. So which means, therefore, this is 150,000 Rand. Okay, next we actually look at the fact that we have the rate of depreciation. It depreciates at 9% per annum. So which means this one is actually 9% per annum. 9% means 9/100 per annum, which is 0.09. So in the end, then, so N is 5 years. So, which means we have the straight line method, depreciation according to the straight line method. It means that we're just going to use simple interest. Okay, this one is simple interest, and we're looking at the straight line method, also called the simple interest depreciation method. 150. What is the I? The interest rate is 0.09. Divide the 9% by 100. And the number of years is 5 years. You use your calculator to do the calculation here. And then now if you open up the brackets, you can multiply it through by the 150,000, getting 150,000 times 1. And then 150,000 times that. So at this point, it means what? It means, therefore, you have 150,000. You multiply this with that, which is that. So which means that it is 82,500. Okay. 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 Calculate the trading value of the old photocopier. So the trading value of the old photocopier will actually be this one. It is exactly 82,500. Okay. So we have answered this finance question. Next question. Okay, you're gonna have a chance to watch this question. Right. So now they are looking at the same a similar question. It is an extension of the question. Is an extension of the question. A company bought a photocopier for 150,000 Rand on 1 July 2022. They will use the old photocopier as a trade-in when they replace it with a new, with rather a similar new photocopier in 5 years' time on 30 June 2027. The company set up a sinking fund. So now we are discussing sinking funds. It set up a sinking fund to cover the replacement cost of the new photocopier. The fund earns interest at a rate of 7.85% per annum, compounded monthly. The company made its first monthly deposit on 31 July 2022 and will continue to do so until 31 May 2027. 1 month prior to the new photocopier being bought, okay, how much should be deposited at the end of each month so that the company will be able to buy the new photocopier? So we want to know, right, how much should be deposited at the end of each month. So normally we are saying X is a question mark in the formulas we're using at the end of each month. Okay, so we are looking for the X over there. Okay, so we continue. We're looking for the X. Right, the question therefore is at this point, what is the sinking fund? What is the sinking fund? So We note that this sinking fund, SF, is the same as the following. Right, so it is the same as the final amount minus the trade-in value. What is the final amount? We got the final amount from the previous question A. We got it to be 205,513. So we know that it is actually 205,513 minus T, the trade-in value. We got it from the previous question using the straight line reducing method, which is 82,500. We subtract these two guys. What answer are we getting? 1, 2, 3, 0, 1, 3. Okay, we've got the sinking fund. We've got the sinking fund. So what do we do now that we have this sinking fund? What do we do with the sinking fund, SF? Right, we actually are able to realize that the sinking fund is actually a future value, and therefore we shall have the future value, which is the future value formula, which is this one here, which is 1 plus I to the power n minus 1. You divide everything by what? You divide everything by I, like this. And so let's do substitutions here. So we substitute the everything here. What is the sinking fund, which is the future value? So it is 1, 2, 3, 0, 1, 3 is equal to X. What is the I? Right, remember that the fund earns interest, the sinking fund earns interest at a rate of 7.85% per annum, right? But is compounded monthly. So which means, therefore, we're going to divide this one by 100. If we do that, we have 0.0785. Okay, it's compounded monthly, so you divide by 12. Then you raise this to the power. What power? We need to think about this. But a couple of things are very important, right? That the company made its first monthly deposit. When was the first monthly deposit made? On 31 July 2022. Okay, it was bought, the photocopier was bought the 1st of July, but the company made its first monthly deposit on 31 July 2022. And it will continue from 31 July 2022, and will continue to do so until the end of May 2027. Okay, so if it's until the end of May 2027, right, you need to look at what this means, and you need to look at, obviously, at the number of the years there. So it tells you that at this point, you have the year 2022, not exactly at the beginning of it, but you have 2027, so it's just about 5 years. But you need to count very carefully. It's about 5 years, because if you take 2027 and you subtract 2022, you will get 5 years. Okay, but taking into account that it's not really the full 2022, the whole thing started in the middle of the year, right? So and also now in 2027, it's not the whole 2027. It's actually until the end of May, 31 May. And so then the question then becomes, how many months will those be? So in other words, you realize that it's actually because if it was a full cycle, okay? So if it was a full cycle, if you start from July and you end in July, all right? So how many months will those be? Okay, from 31 July 2022, how many months were up to the end of the year? Okay, and also up to the 31 May, end of May, how many months into the end of this? Okay, but most importantly, how many payments here? Okay, so in other words, there's going to be a payment 31 July, and there's going to be a payment end of the next month. So you have July, August, September, October, November, December. Okay, so this is going to apply for the year 2022. So it's going to be 1, 2, 3, 4, July, August, September, October, November, December. So it's 1, 2, 3, 4, 5, 6. So it gives a total of 6 payments here. Okay, and then now into 2027, you have up to May. So how many months are those in May, in 2027? So you would start in the year 2027. So yeah, let me just write 2022 here. Right, you have seen that there's going to be 31 July. There's going to be August. There's going to be September. There's going to be October. There's going to be November. There's going to be December. And then now you have 2027. Right, so it's January, it's February, is March, right, so it's April, then it's May. All right, so we have this. Right, we are finishing this question quickly. We're just analyzing the periods. I just need to make sure that you can, normally they do this in the exam, so you might get your periods wrong. You might be having a couple of ways that are easier for you to have calculated the periods here. So this is February, and this is March, April. So obviously here it gives a total of 1. You can do 1, 2, 3, 4, 5, 6. So because you have been told that the company made its first monthly deposit into this. So in other words, you have 6 payments here. And here, the same. You have 1, 2, 3, 4, 5. So in 2027, you have 5 payments. Okay, so now you have those payments there. Right, you have a total of therefore 11 payments. So you have 11 payments here altogether. But remember that these are just the months that are between the years. So now this is 2022, that's 2027. But you know that the years are 2022, 2023, 2024, 2025, 2026, and then you have 2027. So we're interested now in the years full years. 1, 2, 3. There are 4 full years. So in 4 years, N is 4 years plus 11 months. What is 4 years? 4 years is 4 by 12 in terms of the months. So it means, therefore, that you take this one to here. So N, therefore, is 4 by 12 plus 11, which is 48 plus 11, which is exactly 59 months. All right, so in other words, n is going to be 59 minus 1. We divide everything by, okay, so we have this one here. Now, there are a couple of ways to do this question. Right, so you have the I in the bottom of this formula for the future value. So it is exactly 0,0785. You divide everything by 12. Okay, because it's compounded monthly. Hope I left some space here. Right, so what we're getting therefore is that we have, from the previous page, 1, 2, 3, 0, 1, 3 is equal to exactly the x into, right, 1 plus 0,0785. You divide everything by 12 because it's compounded monthly. Is 59 payments here, minus 1. You divide everything by 0,0785. You divide everything by 12. So we want to get the answer. And so to get the answer, you'd have 1, 2, 3, 0, 1, 3 into 0,0785 divided by 12, which is x into 1 plus 0,0785, 59. So we want to get x, so we divide by this here. So is 1, 2, 3, 0, 1, 3, right, into 0,0785. You divide everything by 12. Okay, and you divide entirely by the following into 1 plus 0,0785. You divide by 12 into, you have 59 here, you subtract 1, and that is x. Right, so the conclusion therefore x is, so if you use our calculator from this, we're able to get the actual answer. Right, so the actual answer will be in rands. So it's actually 1,704 rand and 01. So we have 1,704 rand and actually 1 cent. And so that is what we're getting here. And that is the answer. So we've been asked this question, and we started by using the future value formula because with the sinking fund, but we need to know that the sinking fund, what is the formula for the sinking fund? The sinking fund can be seen as the final amount minus the paid-in value. So that gives us the sinking fund. And we substitute the sinking fund because the sinking fund is a future value. So we use the future value formula there. Okay, so there are a couple of notes to take down here when dealing with sinking fund calculations. Next question. Right, so there's a guy called Andrew. Today, Andrew borrowed 200,000 Rand from a bank. The bank charges interest at 5.25% per annum, but is compounded quarterly. Andrew will make repayments of 6,000 Rand at the end of every 3 months. His first repayment will be made in 3 months from now. How long in years will it take Andrew to settle the loan? Okay, let's look at this one. Let's look at exactly this question here. Okay, this one is a loan question. So now loans are present values. So if the examiner mentions a loan, it means we're speaking of money and money that is available now. So it's a present value. Present value is x into 1 minus 1 plus I divided by I. Okay, Andrew borrowed how much money? Now, Andrew borrowed exactly 200,000. So you can start quickly and say, okay, Andrew, there's 200,000 that Andrew actually borrowed. We have the repayments are called X, right? So this 200,000 is the present value. So this one is 6,000 into 1 minus 1 plus, what is I? I is this one here, 5.25%. So it's actually, you divide this, but it's compounded quarterly. So you divide this one by 100. Dividing 5.25 by 100 gives us 0.0525. You divide everything by 4 because it's quarterly. You consider the period, right? So Andrew will make repayments of this at the end of every 3 months because it's quarterly. It means every 3 months. His first repayment will be made in 3 months from now. He's going to make his first repayment in 3 months from now. How long in years will it take Andrew to settle the loan? Okay, right. So we have these. We have these. So now here we don't know how long in years. So we're going to multiply n by 4 here. And we actually divide everything by I. I is our interest rate. And therefore the interest rate is actually 0.0525. You divide everything by 4. So, right, so if you divide, you multiply everything. So if you cross multiply this one by this and divide by 6,000, you'll get 7 out of 16 is equal to 1 minus 1 plus 0.0525. You divide everything by 4 and you have minus 4n. Okay, so you have this. So what do we get? So you have 9 out of 16, which equals 16 to 1 divided by 1,000. If you simplify everything here, simplify everything within the parentheses, you're able to get 16 to 1 divided by 1,600. And you're able to raise everything to the power minus 4n. Okay. Goodness me. Minus 4n. You have the log. 9 out of 16. The log. 16 to 1, 1,600. And then, okay, if you use the log, then you can take the log of this divided by the log of that. You can do it in a couple of ways. You don't understand that? Okay, it's okay. Right. Right, if you take this becomes minus 4n equals the log of this divided by the log of that, use a calculator, it becomes minus 44, 1243. You divide through by 4, which means is minus 44, 1243. You divide it by minus 4, which means n is n is 11,03 years. So how many years will it take? It will take Andrew 11,03 years to settle the loan. So it will take him 11,03 years to settle the loan. Okay, so we have this one. Next question. All right, the next question that came in June 2023 is obviously these are pretty straightforward, and I know that it's one of those sections where students scoop the most marks. If you're speaking about calculus and optimization, the students really scoop distinctions in this area. And let's just see how well you can scoop the marks here. Determine f primed of x from first principles and the rest of the questions on the derivatives and the rules of differentiation there. Question 7 came in June 2023, and now we shall be in a position to solve each question. I've broken this question down to digestible pieces. We look first at 7.1. Right, 7.1 is about the first principles of differentiation. Right, so this one. F primed becomes the limit as h tends to 0, as h approaches 0, of f into x plus h minus f of x, all divided by h. This is the limit as h tends to 0. The f at x plus h, wherever there is x, you put x plus h into the function. So this is minus 2 into x plus h squared minus 1 minus 2x squared minus 1. You divide everything by h. And this is the limit as h approaches 0. You have minus 2 into, if you square these, it becomes x squared plus 2xh plus h squared. Okay, so it distributes, it becomes 2x squared plus 1, which you divide by h. So which is the limit as h tends to 0. So this is minus 2x squared minus 4xh minus 2h squared minus 1 plus double x squared plus 1, and all of these is divided by 8. So we have the limit as h tends to 0 here. So what is this? Right, what is this? So okay, we have this. We divide everything by h. And this is the limit as h approaches 0. So you have, you can plot a common factor h here. And if you do so, you get minus 4x within the parentheses, and you have minus 2h. You divide by h. You cross everything out. This is the limit as h approaches 0. So it's minus 4x minus 2h. As h tends to 0, it becomes minus 4x minus 2 times 0. So you continue and you write the final answer here, which means f primed of x is the same as minus 4x minus 0. And therefore the answer is f primed is minus 4x. Okay. We have this one here. All right, so this is what we have found, and the answer is exactly minus 4x from the first principles of differentiation. So this is one way to do it, but there are a couple of other ways to solve this problem. All right, so this is okay, and we continue to solve more and more questions as we move along. All right. Okay, the next question that came in June this year is about how to find the derivative of this function here. How to find the derivative of this function here. Right, F primed. So we use the power rule. What does the power rule say? Right, it says that x to the power n implies that dy dx is nx to the n minus 1. So which means f primed of x is 3 pi minus 2, which is minus 6x squared plus 6x. So that is the answer. So at this point, if you have this, and we get the result. Okay, minus 6x squared plus 6x. And this is the answer to the question. Next one. Okay, we have to do this one as well. And let us get the answer to this question. So, which means this one here is y equals 2x. Then in the denominator, you can spread this one into the square root of 4, the square root of x. So this is 2x. The square root of 4 is 2, then the square root of x. So this is actually 2x. And then you have 1/2. You can write that one like this. And this is 1/2, the x to minus 1/2. Good. So let's find the derivative of this. So the derivative dy dx, the derivative of 2x, okay, the power is 1 there. So now you bring down the 1, x, and then you subtract like this. Okay, so you have this one here, plus 1/2. Minus this, and you subtract 1 from this. So it's minus this, subtract 1 like this. So it means dy dx minus 1/4 minus derivative. Okay. This is what we get, but we can write everything with positive indices. It's nicer to write it with positive indices for our dy dx. It becomes 2 minus 1 over 4x to the 3 over 2. So that is the answer. Right, so at this point, we're able to find the answer, and this is the answer for 4 marks. Next question. 7.3 is an interesting one. The graph y equals f prime has a minimum turning point um, at, at 1 and minus 3. Determine the values of x for which f is concave down. For which f is concave down. Right. So this is an interesting question. Okay. I'm gonna give you 2 minutes to try this question. I'm gonna give you 2 minutes. Okay, each one of you. Each one of you, what do you think about this question? Okay. Okay, I'm giving you 2 minutes. So you will let me know what you think. Okay. Right. So when you're done, you let me know. Right. So, right, I'm giving you a chance. Okay. Who wants to try? Okay. Anyone? Anyone home? There's no one home. All right, you are afraid. Some of you guys are scared because now, okay, there are some notes. There are some notes that um there are some notes that I want to give to you. What are the notes? Okay, there are some notes. This question is going to be there in November, but I did not get an answer from you guys, so I'm worried, you know. I'm very worried. But there's a table you need to learn. The table is like this. Okay. Because if you have notes, then you can never go wrong. Yebo. You can never go wrong. You'll go right always. Always. So now you can have this one here. F prime of x is negative, but also f prime of x is positive. So which means that if it is f prime of x is negative, this case is the case where the second derivative of x is positive. So you can have here the second derivative of x is negative. Okay, we continue. For this one here, it's concave up, concave up. For it's concave up, concave up. Okay. In other words, if the second derivative for the inflection points is positive, then it's concave up, concave up. Okay, so it can also be concave down when the derivative is negative. The second derivative is negative, but the second derivative can be negative and the first derivative being positive. Okay, but if the second derivative is negative, it means that it is concave down. Concave down. Concave down. Okay, this is the table. So once you know this table, then you are done. What does the examiner is saying? F is concave down. So if F is concave down, they are speaking about the fact that there, that means the second derivative of x is what? Is negative. Okay, so it's concave down. But you need to determine the values of x for which f is concave down. Okay. Okay, all right. Is Waruna here? I think I lost Waruna. Just 1 minute. Okay, I lost Waruna. Okay, that's fine. We're just checking there. Because he's not there on those who are connected. So determine the values of x for which f is concave down. So if f is concave down, then it means that we are looking at the part here where the second derivative is negative. But it can mean that the first derivative is negative or the first derivative is positive. Okay. Now, so you continue. Okay. So let's do this. Determine the values of x for which f is concave down. But remember that y equals, the graph of y equals the first derivative, y primed of f primed of x, has a minimum turning point at 1 minus 3. So if the graph y equals f primed, in other words, is the graph of the first derivative, not just the graph of what? Not just the graph of f. Okay. So obviously here we're saying f is this. You are saying f is concave up. We're saying f is concave down. We're saying f is this. But the examiner here is not referring to the graph of f, but is saying the graph of the first derivative has a minimum turning point at this point. So now, if it has a minimum turning point at 1 minus 3, you need to find the values of x for which f is concave up. Okay, when f is concave down, excuse me, so it's like this. But now, what do you know about the first derivative, f primed? Okay, so if it's concave down, the first derivative can be either negative or positive, right? But at this point, you have that this one has a minimum turning point. It has a minimum turning point, right? If it has a minimum turning point, it means a couple of things. All right, it means a couple of things, because if the graph once again is concave down, it means that you have this kind of a shape for the graph of f. Right. So if you have that kind of a shape for the graph of f, for when it's concave down, right. But the examiner is then saying y equals f primed has a minimum turning point. Minimum turning point means that you have this. Then the turning point is there. The turning point is there. All right. So if the turning point is there, now the examiner is then saying you need to determine the values of x for which f is concave down. Right. And so obviously the answer is very clear now. I'm sure, but you need to obviously think about it. It means, therefore, if this is the minimum turning point at this point, right? So it means, therefore, x must be less than 1. It means x must be less than 1 because you need to determine the values of x for which f is concave down. And so if f is concave down, it means therefore x must be less than 1. All right, so because in other words, you are considering the part if the minimum turning point is at this point. Right, and this is the graph of f primed of x. Right, and now the graph of f prime of x has a minimum turning point at this point. What does that mean? Right, it means obviously you need to determine the values of x which is concave down. So x, the answer is x less than 1. So in other words, you must consider the part that is before that. Okay, there are a couple of ways to think about this question, but that is one way to analyze that. That's one way to analyze that. But also, if the examiner says the graph, this one, f primed, has a minimum turning point at 1 minus 3, it means a couple of things. Right, because if the graph is like this, how can you draw the graph of f? Because it means here the derivative is what? Is decreasing, 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 decreasing. And then here the derivative is what? Is actually increasing, 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 increasing. All right, so that is the kind of experience you're actually seeing. So how does that relate to the graph of f? Right, so in other words, the graph of f should be somehow like this. Okay, the graph of f should be somehow like this, and therefore the values of x for which it is concave down will actually be essentially when x itself is less than 1. Think about this and make sure you understand that. Next one. Right, I'm going to take a break now because this is a brand new question. It's a full question. I'm going to take a break because I started at 9 a.m. I know very well that the other one, Marang, joined us in the middle. Okay, she started at about 10, but I actually had the rest of the crew much earlier. So I will actually make time available to continue with our discussion. Right, ordinarily, this discussion must last for 2 hours. Right, I actually, one learner left obviously because she felt she got disconnected. Her network was bad. Right, so we need to meet again. You let me know when, because in particular Marang, yes, we're supposed to have 1 extra hour. For example, we need 2 hours. Right, and so we have to apportion the time and see how much time therefore we can allocate to continue with our discussion and to see what else we can do. This is a full question from the June 2023 paper. We'll chat then on WhatsApp obviously at different times. I'm going to pause this video in the next couple of minutes. Okay, I'm going to pause this video in the next couple of minutes so you can access the video. But I must thank you for joining us for now. And take good care. We shall talk to Marang and see when we can discuss, what time and when. But we shall talk to Mpo as well. We need to work extra hard. But thank you guys for joining us. We'll chat then on WhatsApp. Thank you and goodbye.
Bye, sir.
Okay, bye guys. Bye Mpo and Marang.
Bye.
Bye guys.